on, or processing the data on which is residing on HDFS. So I just wanted to show how Yarn is different from the MapReduce. In MapReduce, we had job tracker here. So this has been replaced by the resource manager, which takes care of only the resources, scheduling, and then allocation, and then monitoring of the individual nodes. That's all what it does. But whereas the individual job management will be done by the individual the application frameworks. Earlier, also one of the key difference between the MapReduce 1 and then this Yarn architecture is that we had the map and reduce slots in the previous architecture. But if you see here, we have something called as container. These are called as containers, which are generic processing units or processing capacities, right? Where not only map and reduce, but any kind of task can be run. If you design your own Yarn application, which can run on Yarn, and you want to run a different kind of process, it could be shell script, it could be a Scala program, it could be a Python program, a C program. It could be anything. Now it can be run on this container, which is the capacity for processing. It could be capacity in the sense a finite amount of RAM and then finite amount of the CPU cores. Right? Now the possibilities have opened up. So what happened further is that a lot of applications have migrated to the Yarn. Thereby, they also can relieve themselves of the resource management, the cluster management. They can focus on their core functionality. So some of these applications that have come on Hadoop alternative to the MapReduce or Impala. There is another application by name Spark. HBase. HBase was there, but HBase is later migrated to Yarn, and then Giraffe. So Impala, it supports SQL queries. You can write SQL queries to access the data on the HDFS with a little bit support of the metadata. You can write queries in the MapReduce and then get your data out. Spark, on the other hand, it is a very powerful. We'll briefly speak about Spark as well. It's a very powerful and promising replacement for the current Hadoop MapReduce, and then it can work on different workloads, not only the batch or online. It can support different workloads. And then we also have HBase. HBase is called as the Hadoop database, which comes under the NoSQL database, the category. Giraffe is another application that has come that has been migrated to the Yarn platform, which enables you to process graph-oriented processing. You have graph data, you'll be able to find shortest path or various other graph algorithms. You'll be able to execute on the Hadoop using the Apache Giraffe. So what is Impala, right? Impala is an alternate to the MapReduce way of processing the data. So Impala has its own the framework. It does not depend on the task tracker or the job tracker that we have shown on the MapReduce 1 architecture, but it makes use of Yarn for resource management, resource allocation. But it has its own daemons running on each of the machine on the cluster. It is aware of the data formats, but when you write a SQL, it understands what exactly you want. It maps to the layout of the underlying data in the HDFS and processes the data and then gives you back quickly. So what Impala achieves is that it is actually cutting down the launching time. If you see a MapReduce job, it takes a lot of time to launch, find out the resources and then launch your maps and reduces all those things. Because the Impala daemons are always running it cuts down on the startup time. It achieves the great performance jump due to this. But internally, Impala also uses the MapReduce. MapReduce processing, it is not Hadoop MapReduce, but